Alright, so here's your guys' video example for the day. I bet you're missing me like crazy, aren't you? um, anyways, so here we go. I'm just going to work through a couple examples. I do hope that things have been going okay in my absence and that you guys are making sense of the work that's been expected of you. But here's the first situation. It says Emily tells you that she scores 32 points in her basketball game. Write down all the possible ways she could have scored 32 using only 2 and 3 point baskets. Use the table below to organize your work. Okay, so remember, kind of the goal of this is we know she scored 32 points. So you guys might not jump to this right away, but to me, when I look at this situation, I want to kind of model it with an equation if I can. For me, that's easier. You guys might not be there, but what I see is if I'm thinking of points as like a variable, and let's call it x, we could use that to represent the number of 2-pointers. So I could put 2 for every 2-pointer she made, because I get 2 points, and I'm going to add to that 3 points for every 3-pointer she made, and I know that that has to equal a total of 32 points. So to me, this equation is really kind of represents what she did, or in terms of how many points she scored. So if I look at that 2x plus 3y equals 32, I can really just put in values. So for example, I could put in 1 for x, and if I put, I'm going to go back to black, sorry. So if I put in 1 2-pointer, she would have to make 10 3-pointers. And the reason I know that is if I put in the coefficients, 1 times 2 equals 2, and 3 times 10 equals 30. So if I add 30 plus 2, that equals a sum of 32 for the total points. Okay, so I could continue this, but one thing I think is going to help you, because we can't make partial baskets, so I think you're going to want to consider using 3-pointers that come out to kind of like an even multiple. So for example, if I were to try to put in 0 2-pointers, she can't make all 3-pointers and get a sum of 32 points. That's not possible because 3 doesn't divide evenly into 32. So that's kind of what I mean by that. So let's think of other options, since we want to stick with whole numbers. So I'm just going to put a line through this because that one doesn't really work. So we could try, what else could we try? Well, I know that 3 times 6 equals 18. And then I could think of, well, if I do 32 minus 18, what does that leave me with? 14? And to make 14 points from 2-point baskets, I would need to make 7 2-pointers, because 2 times 7 is 14, and 14 plus 18 equals 32. So that's an example that would work. So really, I would think of another 3. We could do 3 times 4, because that would be 12 points. And then I would need to make 10 2-pointers, because 2 times 10 equals 20, and 20 plus 12 equals 32. Okay? So again, I'm just thinking of multiples of 2 and 3 that combined, or summed together, would equal 32. I could choose another example for 3. Let's say 3 times, what else? 3 times 8. 3 times 8 is 24. And then we know we need to get 8 more points from 2-pointers, so 2 times 4 would give me those 8 points from 2-pointers. So I think you guys kind of have the idea, so I'm going to move on to another example. But again, this is really modeling a situation and trying to think of values that would work. Okay? So in this next example, it gives you the equation, and this one's a little bit more straightforward. This is just more of a math problem, so x plus y equals 3. Okay? So if I make x 0, I need to make y 3, because 0 plus 3 equals 3. I could do the same thing. If x is 1, you guys know y has to have a value of 2, because 1 plus 2 equals 3. I could just keep going in this nature. If x is 2, y has to be 1, because 2 plus 1 equals 3. And if x is 3, y is 0, because 3 plus 0 equals 3. and so on. And I can make this, I could also go into fractions or negatives, right? If I make x negative 1, then x would have to be, or excuse me, y would have to be positive 4, because negative 1 plus 4 equals 3. I can make it a half. If x is a half, I know a half plus 2 and a half equals 3. So that would be another example using fractions. So there's flexibility here, but the problem just really asked for 5 solutions. And then it does ask you to plot them on the coordinate plane. For time's sake, I'm not necessarily going to do that, but remember, if we're thinking of the coordinate plane, and I'm just going to do a quick little, we know we have horizontal and vertical axis. So if x was 0, y was 1, 2, 3, right? So there'd be a point. If x was 1, y was 2. When x was 2, y was 1. And I know my graph's kind of tiny here, but what you're going to notice is you should see a line passing something like that. Okay? So one more example I'm going to do for you guys, and then I'll set you loose. I know this is getting a little lengthy. But the other problem type you might see is something like this, and it asks you, will you choose fixed values? So I think what the question is really saying is, how are you going to choose your values of x and y? And I just want to point out something, and I know you guys are pretty opposed or don't like fractions, but when I see this value, 2/5 of x, if I want that fraction to go away, I just have to choose values of x that are multiples of 5. Because if I put 5 in place of x, 2/5 of 5 equals 2. So if you're wanting to get more of a whole number out of that multiplying by a fraction, in this case, since we're working with fifths, I would encourage you to put in values that will give you whole numbers. And by putting in multiples of 5, that'll hold true. So for example, if I put in, and if I want to think of this as what are the values of x and y that will work with this equation. So if I put in 5 for x, 2/5 of 5 is 2, so I'd have to add 9, because 9 plus 2 equals 11. So in this equation, what that looks like, here I'm just going to, sorry, maybe I can't do that. Whoops. So if I were to put in another value, so for example, let's just put in 10. So if I put 10 in place of x, so 2/5 of 10 would be 4. And 4 minus 11 is 7, so I would have to put a 7 in, because 4 plus 7 equals 11. So again, I'm just putting values in, and the reason I'm choosing these multiples of 5 is to make this easier. 2/5 of 15 is 6, and so this would have to be 5. And I think you might notice a pattern. For every 5 I put in here, my y values are going down by 2. So notice as this is going up by 5, these are going down by 2. Just noticing a pattern. So are there specific numbers? I think the multiples of 5 that would make this work easier. Okay, hopefully that helps. Sorry, it was a little lengthy.